Welcome to Spaceverse, your portal to cosmic adventures. Scientists have just discovered something quite strange about the universe. New photographs captured by the James Webb Space Telescope have revealed that an unknown and mysterious phenomenon has existed since before the Big Bang. These findings have sparked intense debate in the scientific community, with some experts suggesting that they could challenge or even overturn our current understanding of cosmology. According to a recent warning from well-known scientists around the world, these results imply that the universe may not have originated the way we once thought. The traditional Big Bang theory suggests that everything in the universe, including space and time itself, emerged from a singular, infinitely dense point approximately 13.8 billion years ago. However, the latest evidence hints that something else, something even more fundamental, may have existed before this cosmic event. Albert Einstein's theories provide some insight into these mysteries. He once described the universe as behaving like a bubble, expanding over time. This aligns with the widely accepted Big Bang model, which posits that our universe has been expanding ever since its explosive birth. Scientists liken this process to the inflation of a cosmic bubble, with galaxies and stars forming within its ever-growing boundaries. However, string theory introduces an even more intriguing concept, one that suggests our universe is not alone. According to this theory, our universe is just one of many, each existing within its own massive bubble. These bubbles float within a higher dimensional space, sometimes colliding or interacting with one another. If true, this means we are not simply floating in a single cosmic bubble, but rather immersed in an endless bubble bath of universes. This perspective raises an astonishing possibility. The Big Bang may not have been the absolute beginning of everything, but merely one event in an ongoing cycle of cosmic creation and destruction. In this model, universes could be continuously forming and collapsing, driven by forces we have yet to fully understand. If these new discoveries from the Webb telescope continue to support such ideas, they could revolutionize how we perceive our origins and the very nature of existence itself. For decades, physicists have sought to unify the laws of quantum mechanics and general relativity into a single, coherent theory that explains everything. The concept of a multiverse, where countless universes exist side by side, has long been a theoretical possibility, but these latest findings suggest that it may be more than just an abstract idea. If the universe truly functions as a cosmic bubble, part of an ever-expanding multiverse, then the implications are profound. It means that the Big Bang was not the first event in history, but rather one chapter in an infinite cosmic story still waiting to be fully understood. Following the Big Bang, we have a strong grasp of how the universe has evolved and how stars, galaxies, and black holes have formed. However, there is still a significant mystery. What existed before the Big Bang? Scientists are astonished because the Webb telescope's results show that something unusual may have happened before the event in question, which indicates that there are gaps in our existing cosmological models. What did we find out, and how did it surprise astronomers throughout the world? During their first investigation of distant galaxies in the 1920s, astronomers made a surprising discovery. They discovered that the great majority of galaxies are moving faster than we are. Initially, this led some individuals to believe that Earth could be the center of the universe. Most galaxies are moving away from Earth, but new studies have shown that a handful, including the Andromeda Galaxy, are actually becoming closer to us. This was incomprehensible to me. After decades of careful observation and analysis, astronomers concluded that space is expanding, not the galaxies. Even though this expansion is more intricate than it seems at first, it does not have a fixed point. Consequently, it seems as though the universe is moving away from you no matter where you are in space. As a result of this discovery, we have learned that the universe does not revolve around a single center point. Everything is moving away from everything else because the cosmos is expanding. Furthermore, scientists have observed that space is expanding and that it is also accelerating. This suggests that the farther away a galaxy is from us, the more quickly it is moving away from our line of sight. New research shows that almost every galaxy in the observable universe is moving away from Earth at a speed that is faster than the speed of light. How is it possible for something to move faster than light, when one of the fundamental principles of physical theory states that nothing can do so. The most important thing to understand when studying the cosmos is special relativity, which is Einstein's groundbreaking theory of relativity. This theory revolutionized our understanding of space, time, and motion. According to special relativity, nothing can travel through space at the speed of light. This is an absolute cosmic speed limit that applies to all objects with mass. However, this principle does not mean that distances in the universe cannot change at speeds greater than that of light. As I mentioned earlier, distant galaxies are not physically moving through space at such speeds. Instead, the space between us and them is expanding, carrying them farther away. This is a crucial distinction. While no object can move through space faster than light, space itself is not bound by this rule. The fabric of space-time is stretching, causing galaxies to recede from us at astonishing rates, in some cases faster than the speed of light. Imagine dots on the surface of an inflating balloon. As the balloon expands, the dots move apart from each other, not because they are traveling across the balloon's surface, but because the surface itself is growing. This is similar to what is happening on a much grander scale in our universe. The galaxies themselves are not moving at the speed of light, or rather, the space between them is expanding at a rate that makes it appear as if they are retreating faster than light. Because of this, they are not violating any fundamental cosmic speed limits. Instead, they are simply being carried along by the relentless expansion of the universe. Scientists widely believe that this expansion began with the Big Bang, the event that marked the birth of our universe. Before the Big Bang, there was no space, no time, and no matter, at least not in any form we currently understand. The Big Bang was not just an explosion of matter into empty space. It was the sudden and dramatic emergence of space and time itself. It set into motion the vast, ever-expanding universe we observe today. When people envision the Big Bang, they often picture a colossal explosion, with matter bursting outward from a single point into a pre-existing void. However, this is not an accurate representation. According to our best cosmological models, the universe did not expand into anything. Space itself was created in the process. At the very beginning, all of the observable universe, including everything beyond what we can currently detect, was compressed into an incredibly small, infinitely dense point known as a singularity. This singularity contained all the energy and matter that would eventually form the cosmos as we know it today. Roughly 13.8 billion years ago, this singularity rapidly expanded in an event known as cosmic inflation, giving rise to the immense universe filled with galaxies, stars, and planets that we see today. However, the true nature of the singularity and what, if anything, existed before it remains one of the biggest mysteries in modern physics. Our understanding of the early universe continues to evolve as new discoveries are made, particularly with the help of advanced telescopes like the James Webb Space Telescope. By studying the light from the earliest galaxies, scientists hope to unlock even more secrets about the origins of the cosmos and perhaps even uncover clues about what, if anything, preceded the Big Bang itself. Contrary to what most people think, this singularity is not just a tiny dot in the universe. That would be the case in a constrained universe. The universe seems to be infinite, but if that is true, then it has always been infinite. As a result, the Big Bang occurred throughout the entire universe, rather than in just one location. This means that no particular region in space can be considered a potential birthplace for the first galaxies. They came from every corner of space and time, including the parts of the universe that we cannot see. It appears that every location in the universe has gone through the identical moment when matter was created. That said, we still do not know why the universe is so flat and distributed, or why it looks the same in every direction if we only consider the Big Bang. Take out your telescope and look in every direction. You will see that, at least in general, it seems the same as before. This is when we come across the idea of inflation. The cosmos had a period of rapid expansion just before the Big Bang, according to inflation theory. In the blink of an eye, it grew from its original little size to its final huge size. This inflationary expansion was caused by a unique energy that was present in vacant space. However, this place that appeared to be vacant was not as empty as it appeared. Instead, it was filled with this remarkable force that made space expand at a dizzying speed, as though the universe was growing inside of a container that was already there. Before this rapid expansion, the universe was a cold, black void. There were no stars, galaxies, or even particles in existence. However, this emptiness contained inflationary energy, which caused the cosmos to expand. Thus, it was not truly empty. The universe looks flat and uniform when we look at it on a large scale now. This is because any bumps or defects in space were smoothed out throughout the expansion of the universe. When inflation came to an end, all of the energy that was stored in space was freed. This sudden release of energy, which is now referred to as the Big Bang, caused the universe to be filled with particles, light, and all the essential components that would later lead to the formation of galaxies, stars, and planets. Inflation teaches us that the universe was a huge, empty space before the Big Bang. It expanded at an astonishing rate due to this unknown energy, and it also helps us understand why the universe looks the way it does. Everything that comes after this portion was built on this stretch. Inflation frequently creates new issues, even though it has been able to resolve some significant problems. For example, when did this inflation start and when did it stop? What was the mysterious power that caused it to move? The James Webb Telescope has discovered even more riddles, which has further contributed to the bewilderment. These new findings suggest that there were unusual things that existed prior to the Big Bang. The James Webb Space Telescope has made an unexpected discovery. The universe is expanding at different rates in various directions. Until now, physicists believed that the universe was expanding at a steady rate. Thus, this is a very important discovery. According to the theory of cosmic inflation, the universe expanded rapidly due to vacuum energy before the Big Bang occurred. Another principle that this philosophy supports is that this expansion should be the same all around the world. On the other hand, if the recent findings from the Webb telescope are correct, they raise questions about our present understanding of inflation and make us wonder why the expansion of the universe is different in different places of the world. Is there any other force besides dark energy that is causing this unequal expansion? Previously, it was thought that dark energy was the reason for the universe's rapid expansion. However, recent data from the Webb telescope suggests that there may be more to the story than was previously understood. It is possible that some unknown factor is having an impact on the direction in which space is expanding. Additionally, astronomers have discovered thousands of red dots in the deep field images captured by the Webb telescope, and these dots are completely inexplicable. At first, they thought that these objects could be distant galaxies. However, after taking a closer look, they are showing unusual characteristics that go against what our current theories of early galaxies predict. The behavior of these things raises the question, what other types of objects may have existed in the early universe? And implies that our current understanding is not entirely accurate. These results are significant because they contribute to the increasing amount of evidence that suggests there may have been a strange event that occurred before the Big Bang and the creation of the universe as we know it today. Nobel Prize-winning experts and scientists are now asserting that there may be a crucial piece of information that we do not currently possess regarding our understanding of the universe. The Standard Model of Cosmology explains how the universe has changed since the Big Bang, even if it does not include everything that happened before the Big Bang. The Webb telescope has discovered new discoveries that suggest there may be more to the story, including events that took place in the vast, empty space before the universe expanded. These discoveries also raise questions about the inflationary theory, which has been accepted for a long time. This theory suggests that the Big Bang was preceded by a rapid expansion that was driven by vacuum energy. We are already seeing evidence that the universe is expanding at different rates in different directions. If this smooth and uniform inflation is what shaped the world, then why did it happen? Before the Big Bang, there might have been something more complicated happening, and it is still influencing the universe in ways that we are just beginning to comprehend. In addition to these expansion anomalies, the Webb telescope has discovered other unusual things in the early universe that do not fit with our existing models. These findings indicate that the early universe may have been more complicated and diverse than was previously thought. According to what we know, the Big Bang may have been a transitional event that resulted from something else totally, the nature of which we do not yet fully understand. Scientists are continuing to investigate these data, and they are growing more open to the idea that our current hypotheses may need to be significantly revised. If it turns out that the universe was created before the Big Bang, during a time when different forces or conditions were at work, our current understanding of cosmology could change significantly. And there you have it. If you enjoyed this deep dive into the unknown, don't forget to like, subscribe, and hit the notification bell so you never miss our latest cosmic revelations. Let us know in the comments, what do you think happened before the Big Bang?